In this question, we're asked to find some enthalpy information for the lead acid storage battery that was invented in 1859 in France and is still in use more than 150 years later. So there are two reactions that take place. One, sulfuric acid yields SO3 plus 2H2O, and then lead plus lead 4 oxide plus 2SO3 yields PbSO4 solid. And this gives off quite a lot of energy, which can allow the battery to work. So what it wants to know is calculate the net enthalpy change for the formation of 1 mole of lead 2 sulfate from lead 4 oxide, and sulfuric acid from these reactions. And this is a Hess's law problem. So basically, we're given two reactions, and we're given the enthalpy of the reactions. And then we want to know something about the enthalpy of an overall reaction for the formation of these compounds and how much energy will be released if we form 1 mole of these compounds. In this case, specifically, 1 mole of lead 2 sulfate. So in order to do this, we need to add these two equations together, and if we add the two equations together, we can add their enthalpies together and figure out the enthalpy of the overall reaction. We can then convert it to find the enthalpy of 1 mole of the lead 2 sulfate. So we're going to have to go ahead and do that. What I noticed is that we need to form 1 mole of lead 2 sulfate from lead 4 oxide, and sulfuric acid. But I also noticed there's sulfur trioxide in both of these equations. So I know I'm going to need to get sulfur trioxide to cancel out because I don't want that to be one of my reactants because that's what the question says. So I need to get sulfur trioxide to cancel out. In the first equation, I noticed that there's 1 sulfur trioxide in the product side. In the second equation, there's 2 in the reactant side. So I know that I need to double this reaction to get 2 sulfur trioxides in the product side so it'll cancel out. One good thing about Hess's law problems you'll face in general chemistry is they generally have a relatively straightforward solution, such as double, triple things, reverse things, so you can flip this equation around so the products become reactants and then make this negative. So there are these types of solutions. They're usually not super complex solutions, and you know you have the right equations. If you're doing this in real life, you don't always know that you have the right equations and the things will cancel out. But here they should. So first thing we want to do is double this reaction. If you double the reaction to get 2SO3 on the product side, you have to double everything. So doubling everything, we get 2H2SO4 liquid yields 2SO3 gas plus 2H2O liquid. And logically, if we double everything, we also must double the delta H. If it takes 113 kilojoules to make this reaction go once, it's going to take 226 kilojoules to make it go twice. So we multiply the delta H by 2. So delta H in this case equals double of that, which is 226 kilojoules, because we doubled the reaction. For the second reaction, we basically want to leave it alone, because now we have 2SO3 already, so it will cancel out. So just leave it alone. So I'm just going to rewrite it. Pb solid plus PbO2 solid plus 2SO3 gas yields 2PbSO4 solid. And since I left it alone, I'm going to leave the enthalpy alone. So delta H just equals minus 775 kilojoules. Now we add the reactions together. Recall that adding reactions means write everything on the reactant side on the reactant side, everything on the product side on the product side, and anything that's the same on both sides cancels out. So starting with 2H2SO4 liquid plus PbS solid plus PbO2 solid plus 2SO3 gas, so all of the reactants, all 4 of them, yields, starting here, 2SO3 gas, the first product, plus 2H2O liquid, plus 2PbSO4 solid. Now, if you add the reactions, you can add the enthalpies, because enthalpy is a state function. Adding reactions means you're allowed to add the enthalpies. So for this overall reaction, delta H equals 226 plus negative 775, which is negative 549 kilojoules. Now we want to write the net reaction, so cancel out the same, anything that's the same on both sides. Sulfuric acid is a reactant, it is not a product. Lead is a reactant, it is not a product. Lead 4 oxide is a reactant, it is not a product. But sulfur trioxide is both a reactant and a product, and there are two of them on both sides, so we can cancel it out. Now that we've canceled out things that are the same on both sides, we can write the net equation, which is 2H2SO4 liquid plus lead solid plus PbO2, lead 4 oxide, solid, yields 2H2O liquid plus 2PbSO4 solid. And the delta H is the same because it's just the same reaction where we cancel things out, which is minus 549 kilojoules. But if we read the problem carefully, it says, what is the enthalpy of formation of 1 mole of lead 2 sulfate? Well, in this case, we're forming 2 moles of lead 2 sulfate, so we have to divide this number by 2. So delta H for 1 mole equals minus 549 kilojoules divided by 2, because we formed 2 moles, which gives us minus 275 kilojoules per 1 mole of lead 2 sulfate. So it will take, if 1 mole of lead 2 sulfate is formed, 275 kilojoules of energy will be released. That's what the negative means. So Hess's law problems are quite involved and take practice. Please be sure to practice several examples of these.